Hey everybody, Paul Chin Jr. here, back with another episode of Talking Serverless. It's a very simple podcast with one very simple idea. We talk about serverless and what that means. And so today, I'm really excited. A couple of our gurus ran into somebody from AWS at the Toronto Summit, and they were super jazzed about his talk there and had to get him on the show, and he so kindly agreed to come on. So now I am proud to introduce the one, the only Sushanth. Hey man, how's it going?
Hey, Paul. It's nice to be here. Thanks for having me on.
Perfect. Yeah. Like I said, some guys ran into you at the AWS show Toronto, and I took a look at some of the stuff that you were doing, and I realized that it kind of tail ended perfectly with the end of reInvent last year, where Werner was all about this complexity and simplexity and just making up words because that's what he gets to do for a living. So I wanted to kind of open with it there. Kind of tell me about you and your role and how that's manifested in this idea of managing complexity for you.
Yeah, so my role is that of a solutions architect at AWS. So if anybody is not familiar or has never interacted with an AWS solutions architect, our job is to ensure that the customers are uh, building the thing right on AWS or building the right thing on AWS. Both ways, we are here to guide our customers, the customers who build solutions on AWS, to make sure that they understand all the options that are available to them and picking the right options for the right job. So, yeah, the complexity naturally is a byproduct of where we find ourselves in the world today with all the different technologies that have emerged and how there has been like a hockey stick growth in terms of the options available to folks to build solutions, not just on AWS, anywhere. So just trying to weed through all of that and arriving at the right solutions. That's where I feel the solutions architect at AWS can be really, or at any organization can be really valuable to a customer.
Yeah, it's sort of helping navigate this idea of complexity. How can we start sort of set a baseline for what we mean by it's too complex? Because in client situations, we are brought in because situations need help, right? If they didn't need help, we probably wouldn't need to be there. They were already doing things quote unquote the correct way. And you know when the issues arise, somebody says, "Oh, this is a really complex system. There's not much we can do about it." In terms of that, what how do you respond to that? Like where do you see complexity being described or being illustrated in these situations?
Yeah, I like to make a distinction between two types of complexities. One is the inherent complexity or essential complexity that exists just because of the business that you operate in. The business domain is complex, right? And that's not something that you can solve just by using technology of any kind, right? That complexity is going to exist no matter what. And then there is the accidental complexity or complexity that technology tends to create. So many times you're solving for complexities that have been created by other technologies using new technology. So that's where the accidental complexity becomes a factor. And that is something that I find myself solving a lot more for, unfortunately. Whereas the focus should really be on solving the essential complexity, but accidental complexity creeps in anyways. But both sorts of complexities are slowing down organizations from realizing full value of what they can achieve with technology. So, yeah, that's my view on complexity.
That's a that's a really great way to kind of bucket it, right? To put it in terms that both the executives and the holders of stakes and all the product owners and all those people, they kind of have this. internal complexity, the business processes, all of the choices, decisions, the value chain that they perceive as the product for their customer. That's one type of complexity. And then on the other side, I guess it is just technology changes and we have no idea where it's going to change to. So we make the best decision that we can at that time. And over time, those just continue to stack up to become, what did you call it? Accidental complexity?
Accidental complexity. Yeah, it's just a byproduct of the choices you decide to make at some point in time. And maybe those choices were right for the time you made it, but things have come along since then. Your business has evolved. Maybe there are cheaper, faster, better options available, but you just chose to continue down the same path, and now you find yourself behind the curve that, hey, I could be doing this much cheaper, faster, and I'm not, for because I don't have budget. I haven't really thought about it. I haven't upgraded my team on these new advancements in technology. So those are how accidental complexities manifest themselves.
Yeah, it's giving like Home Alone vibes, you know. You're setting up all these traps and then you walk into them yourself. You're not exactly sure how you got hit in the face with a paint bucket, but you remember putting it up there. Um, I like the accidental approach to it as well because no one really opts into a poor system on purpose, right? Like I've been doing this for a few years now, and in every situation, everyone's just trying to do the best they can. But it does take nuance and expertise of the tooling to really apply it correctly, like you mentioned, as a solutions architect would do, right? So, you know, now that we have these two different buckets, there must be some intersection in the middle where everybody gets confused, right? Like that's why we have these issues. Or is it that we only focus on one but not the other with the wrong solution? I don't know. Like kind of walk me through, what is it like to really blend these two ideas and start to tackle them?
Yeah, that's a good question. I think there is definitely an intersection, and the intersection sometimes is less obvious than you think, right? Like we are building with this particular database, we are building with Kubernetes, or we are building with a- any technology that you can name. But are you able to answer the question why, right? That why becomes really important. What led you to picking this option in the first place? Are you able to reason about it? Are you able to trace back your steps to how you arrived at that situation, or the choices that you made? I think that becomes really important in unwrangling some of this complexity, because if you're able to describe, yes, this was the situation that led to us picking these tools to build with, then usually you have a good idea for how you can start to go back and simplify some of the complexity that you created for yourself. Because knowing the problem is half the battle, right? Once you understand the problem, you can solve for it. Otherwise, the answer usually tends to be, oh, this predates me, or we are not sure why we are doing it this way. This is how we have always done it. And that's where it kind of becomes harder, because the business doesn't care, right? The business doesn't care whether you solve it using Kubernetes or serverless or any technology that the architects decide to build with. They just want to see the business outcomes. So when they outline the budget for an year, the technology budget, they're just hoping for the architects to make the right choices in ensuring that business outcomes are achieved, but they don't really care how you're doing it. So it's up to us as technologists to figure out the right set of options to pick to ensure that the outcomes are achieved. So I think there is that intersection for sure, but uh, us as technologists, I feel, have more of an ownership of that, because the business just needs to focus on getting the business outcomes, right? Like the CEO and the CTO relationship is kind of like CEO has a CTO to help him not have to think about technology or the choices that you need to make. Uh, so the CTO can wear that hat and think from even a business perspective.
You do have to think about both sides often. And one of the things that I really learned to lean into when I started here at Serverless Guru really was the concept of ADRs, architectural decision records. And I've been on the road for the past couple of months giving talks at different conferences. And one of the takeaways that I have is if you really want to be a true 10x developer, create an ADR and just check it in with your repo. In my example, I said we're going to use Athena because we're only doing ad hoc queries and we don't need another database. Done. Now we know why that layer is there. Maybe there will become a need for a database, but to your point, like that's what we're trying to establish. Like, so how can we get to an environment where engineers and executives are able to communicate these kinds of things, right? Because if we have these good records of why decisions were made, then it shouldn't be as big an issue to make something happen, right? But we don't see that. You know, what are you doing with organizations or with other engineers to kind of lay that like groundwork, to lay that example?
Yeah, I'm glad you mentioned ADRs because a big portion of my conference talks that I've been doing recently also focuses on ADRs and the importance of those. Many people seem to know about ADRs, but when I ask them, do you implement it within your organization and do you have like a process around ADRs? The answer is usually no. So everybody understands why it could be valuable or sees the value in it, but nobody has the rigor or has an established practice around doing it correctly or doing it on an ongoing basis within their organization.
You know what?
Yeah.
I think I know how we can get developers on board with this idea. We have to tease them and say, well, if you're not going to make an ADR, then you have to fill out the Confluence page.
Yes. Yeah, that'll get them.
That'll get them right. Like if you really want to get rid of Confluence and Jira for the rest of your life, just make good ADRs that somebody else can come back through, read the markdown, and then be like, okay, at least I have a starting point. It may not even make sense, but at least I have a starting point.
Yeah. Now, but going back to your original question, yes, there is that what I call a translation layer that us as technologists become. We are the medium. So, as architects, especially, I feel like we should speak the business language just as well as the technology language. And we are that translation medium that gathers the objectives from the business and translates that into the technical specifications that the engineers will eventually implement. Of course, if you're a hands on architect, you are just as involved in the building process as well. But I feel like understanding that business context and even sometimes reasoning with the business, right? Because the business may sometimes have very ambitious goals, which may not be feasible with the constraints that you're operating with, right? Like you have limited budget, you have limited time, you have limited staff to execute on your vision. So sometimes it becomes a negotiation process as well, where the architect needs to talk to the business and say that, hey, I can do this for you, but in return for that, I may have to trade off on these things. And the business has got to be okay with it, or they got to give you more time and more budget. And if they are willing to give you more time, then yes. I always say that if you have infinite time and infinite budget, you can build the best systems in the world every time. But not all of us are afforded that luxury. So we have to operate within some constraints.
You know, I tell you, even the folks that have unlimited budget, they are still not able to build things at the best level, right? I think we've seen lots of examples of all the top tech companies in the world just screwing up same day after day, right? Their models are messed up, or they allow client input. You know, they don't sanitize client input. It's just basic stuff, right? And they have unlimited literal money, and they just keep throwing at it. And you know what? It's okay. Come back down to our level, and we will do the best we can. And really, software is nothing but trade offs. It's like, how many different paths can you remember, and then choose the one that you think that you think is gonna actually work. Like I said, nobody sets out to build a bad system. We're all just trying to, make this stuff work. And there are constraints, there will always be constraints. And the thing that I want to kind of switch ideas for you is, well, we can solve this complexity with other services, other abstractions, and then vendors promise simplicity. All right. So they're like, yes, come on over here. It's much nicer. You don't have to think about any of those things. Yet somehow complexity continually creeps back in. Right. Can you tell us about a time when you thought, we got this, this is fine. And then all of a sudden, complexity comes up and you're not sure again what to do, and like, why does this keep popping up?
Yeah, and this goes back to uh, the time when I was not even at AWS and I was working at enterprises. And I used to have these exact same conversations with vendors who would come sell us this point and click, no code, low code solutions that will magically simplify your life. I don't want to name any vendors here, but you probably know a few of them. But they would come and give us a nice demo and then show you how easy it is to build an app, and then you can go to production in few weeks, and all your problems are solved. But the complexity emerges from the things that you can't see, right? What's really going on underneath the no code low code solution that you're using? Where are certain things lost when real production issues occur and you want to troubleshoot and get to the bottom of them? uh, that's when you find yourself really struggling to figure out, hey, how does this thing even work, right? Because everything is hunky dory when you're doing a demo or you're doing a POC, but when real users start using your system, complexities or situations can occur in new ways that you may not have seen before. If it was your own code or if it was something that you understood and built yourself, it's something that you can really find and troubleshoot rather quickly. Of course, you may still need to explain to your end users that, hey, we have this issue. But if you're not even able to tell your end users how long it's going to take to troubleshoot something, that's not a good experience. So, yeah, I can completely resonate with what you said before. So, yeah, it's not always about hiding the complexity under multiple abstractions. I think it's more about understanding the complexity and being prepared to solve for it at different stages.
Exactly. Yeah. I sometimes I think solutions confuse like simplicity with just abstraction, right? It's a bit too much magic. I've been in the dev tooling world before, and engineers really like to see like a good amount of abstraction so that they feel like they're achieving something, they're being productive with it, but not too much so that when there is an error, those errors are silent, or those errors are not observable, right? It's locked behind an API. And so that actually, have you ever checked out like network science or like network theory? And this idea of a small world network where if you have a bunch of like nodes on a circle and they all communicate with each other just contiguously, it's like, okay, yeah, cool. But as soon as you add one or two extra, they call them shortcuts, then all of a sudden, bam, complexity just starts to happen and like hubs emerge. I watched that all in like this YouTube video from Veritasium this week, and I loved that illustration, and for folks that are listening, go check out the Veritasium thing about complexity and think about your networks and think about your own software in terms of you have these nice little clumps of nodes that you control, but then once you start connecting them to each other, it spirals out, right? It doesn't just go up slowly. Those extra connections make things much more complex much more quickly. I find that's also true like in our systems.
For sure. Yeah, that's very well seen when folks move from monolithical architectures to microservices. Sometimes they underestimate the complexity that comes with a microservices architecture, and the fact that all of your local function calls or RPC calls are suddenly now going over a network. And there is this fallacy of distributed computing that was documenting about 7 or 8 fallacies where you assume certain things about calls that are made over network to be working as though they are being made on the same host. That's not always true, and newer complexities emerge. And as you add more microservices, that tends to again magnify and spiral out of control if you do not have the right level of distributed tracing or observability in place to understand the health of your system from the context of the entire system, right? Not just from the point of an isolated microservice. So, yes, I can completely understand what you're talking about.
Yeah, so I guess we've hinted at serverless a couple of times by now, and this is talking serverless. So, where have you seen the use of serverless even making a dent in organizations?
Yeah, so serverless, it is rather surprising to me even now that serverless has been around for more than 10 years, I think, at this point. And from the time that the term was first coined, I think the understanding still remains very narrow that it eventually comes back down to I don't want to use AWS Lambda. This workload is not a good fit for AWS Lambda. And I can understand that. Not all workloads are a good fit for AWS Lambda. But what I like to emphasize usually is that serverless is so much more than just AWS Lambda. There are so many things on AWS that are serverless. Many customers don't realize that SQS is serverless, SNS is serverless, DynamoDB is serverless. So sometimes serverless gets synonymized with AWS Lambda, and that can be really limiting for organizations who can really derive value from serverless. And they find themselves not taking advantage of some of the benefits that come from adopting serverless technologies. So, again, I can rattle off names of all the different services we offer under the serverless umbrella. But until you change that mindset and think of serverless as things that you do not need to own and operate yourself, and that drives your thinking, I think you're in a better position to take advantage of what serverless has to offer.
Yeah, I mean, it is. I think serverless is fairly mature now. I mean, they you can run a container inside of a Lambda. Why? Why would you? I don't know. I never got to that point. Do you actually know why you would run a container inside of a Lambda?
Yeah, and that's a good use case for when you want portability or you think about portability. That sure, I'm running in AWS Lambda today, but what if I want to actually run this in Kubernetes tomorrow? So if your workload is already containerized, then it's just a matter of rehosting it on Kubernetes at that point. So it gives you that flexibility that you become compute neutral and you're still getting all the advantages of what containers offer in terms of course, in a Lambda, you would always run just one container. But the reason customers even move to a container-based architecture is that they get better resource utilization. There's better isolation between multiple workloads that run on the same host. But it gives you that flexibility when you want to have that compute neutrality And sometimes lambdas can feel like, oh, I'm writing code directly in the console. Of course, you're never going to do that. You would still write it in an IDE and promote it to an environment where it'll run in a Lambda function. But it's scary that a developer can go and edit the Lambda function right in the console, and it could be lost. The versioning could be lost, and you don't know what state you find your Lambda function in. So for that reason, again, containers is like a safety net. I've not seen a whole lot of containers being run in Lambda, but yes, the option exists.
Yeah, I mean that's where we're at, right? And even over all of that time, I feel like AWS has even created ways where you don't even need lambdas anymore. You can just connect services to services over Event Bridge, and then there's enough inherent metadata in the message itself to carry out some operation, right? And then now we can do lambdas without an API gateway. They just get their own URL, which is kind of crazy, right?
Mhm.
And hopefully, I don't know. This is just my wish. You can tell me if you think this is a silly wish or not. Like, I really want regionless. Like, I don't even want to have to say I'm in UST Swan. I can say like, all right, here are my pops, and like here are my CDNs. You figure out the rest. Like, I don't know if we'll ever get there, but I can dream, right?
You're not the first one to ask for it, honestly. We do have a couple of regionless services today. IAM is regionless. Route 53 is technically regionless. I think CloudFront to some extent is also regionless. But the reason compute and databases and other services are region aware is because of the data residency requirements and all the compliance aspects that go with it. So AWS always likes to think of our cloud as more of a general purpose cloud that a hobby developer can use, but also a financial institution who's running millions of billions of dollars of transactions on a daily basis can use. So we need to find that right medium. And some of those organizations who care about compliance are really, really picky about the regions that they operate in and where they want their data and compute to run.
Man, what a great answer. I've asked that question around, and yeah, I never thought about the geographical restrictions of physical custody of data, which makes sense. So I'll just have to just keep waiting until the till that shakes out later. But you know, with serverless and with different cloud native services like S3 and even the new like Aurora DSQL, that's cool. That's serverless, right? Like that gets rid of the idea of having to save even like a database, login and password. You don't even have to save those, into some secret store. It handles it all by IAM. Like I feel like these kind of ergonomic trade offs for developers um, or just maybe people haven't seen it enough because I thought it would really take off, like even more than it is now. But when I go to conferences, people still only think they're lambdas, and they still think it's just for like not like one-off workloads. Because at first that's what we did. We were like, okay, let's just get started. Let's do some one-off workloads.
Hmm.
So, have you seen the adoption of it really take off with your expectations, or are people just sort of still set in they want full like autonomy in their configurations, or what's your experience with that been?
Yeah, I still observe a lot of customers not fully embracing the idea of serverless. And I think that's more to do with not fully understanding what it can offer to their business, plus being ingrained in how they've always been doing things, right from data center to first migration onto AWS and continuing to operate using VMs on EC2 instances. They get comfortable with that, and I don't blame them. We all love inertia to a certain extent, that hey, why fix something that's not broken? And yeah, I've seen both ends of the spectrum. I've seen customers who operate multi-million dollar businesses purely on serverless. They make they bring in a lot of revenue for their business, but AWS does not see much revenue because they're operating on serverless. So they're not spending a lot. They're taking advantage of the free tier that comes with Lambda, and they're not paying for the time that they don't see traffic. So all of that results in them operating in a very efficient manner. They have a very lean engineering team because they have taken advantage of all the automations that come with serverless. And I try to sell that idea to some of these other customers who come from a data center mindset. And for them, it's like a whole new world, right? Like they don't really first tend to understand that this is even possible. But I always recommend them take baby steps. Pick a workload that you think can be serverless, or I'll work with you to find out a workload that we can carve out as a serverless first workload and see where that takes us. Of course, at some stage, if you anticipate that you will have always on traffic 24 cross 7 and high throughput traffic, maybe lambdas will turn out to be more expensive than you would desire. At that point, you may want provisioned compute, but not all workloads are going to be that way. So there is always opportunity to carve out serverless workloads from even some of the larger monoliths that you have today.
Yeah, it's really even you have to think about it broader than just compute. Like, what kind of compute are you looking for? Is it something going to be like Kafka-y? Maybe you can use SQS, you know? Even if you can't use SQS and it's outside the message format you want or whatever, you can still use a managed Kafka that would kind of help, right?
Yes.
Another thing about adopting this idea of serverless first that has to happen is also redefining the roles of like what is a developer and what is an operator and like whose team it does what and how. And what I've seen just emerge recently as this idea of like platform teams. These platform teams now take care of all of the like AWS API stuff, and they just kind of vend out environments or just vend out credentials to their developers. But that can't be the only way, or is that the best way? Or how have you helped these organizations kind of adopt maybe new team lines?
Yeah, platform engineering has picked up quite a bit in the recent times. And I think it's to the advantage of developers who don't want to concern themselves with infrastructure. So I come across many developers who feel like uh, their job is to just write the best code that they can and get the application up and running. Then they don't really care where it runs and how it's operationalized in production. And I can see their point of view, right? Because that is them making the best of the skills that they are trained for. And for them, I think platform engineering becomes really useful in that they get this one click environment provision for them. They just use that environment to deploy their code when it's ready. But I've also seen other developers who are really interested in the intersection of where the application code meets the infrastructure, and they want to understand how their code gets deployed into a production environment and get that full cycle experience of knowing exactly how the code eventually becomes, because that intersection cannot be ignored. Sometimes how you may have designed your program to run or your application to run may be at odds with how it eventually gets deployed into production, right? For example, if your application is a high CPU application, and if the right amount of CPU is not provisioned for even your Lambda function, it can make your application look slow, even though it is not technically written to be slow, right? It's the way it has been deployed that is making it appear slow. So all of that becomes a factor. I think my advice there would be that even if you have a platform team, the platform team should be open to producing information to developers who want to understand what's going on behind the scenes, what is making up the environment that they're building the code for. So abstract enough from the developers to make their lives easy, but don't hide things away from developers who are keen to understand what's going on.
Yeah, that's the fine line we've been walking this entire episode, right? Like, what is simple enough? Like, am I good enough with just Vercel? Like, all I need is something like Vercel. Okay. that's that's as complex and as simple as it gets right now. You launch a React app, and everything's already pre-interconnected, and you get all your DNS done, you get all your preview builds done. Like, it handles CI/CD. All you gotta do is check in code.
Hmm.
And underneath, they're just using AWS. And you can even write lambdas. They just call them something else, right? So I think this model of computation is going to be proven out, and people will still keep doing it. But, you know, what other things are there in this accidental complexity, that's, maybe a little bit other technology related stuff besides platform or deployment choice? What else is in there?
Yeah, I think a lot of times it has to do with what kind of, uh, again, I go back to constraints because that comes up a lot. The constraints that you're working under, which can both add to the complexity but also lead you to the right solution. So feel like constraints are not always a bad thing. Sometimes it limits your options, but the limited options can also make it easy for you to land at your eventual technology choice. So that tends to make your decisions easier when you sit down to define your solutions architecture. Uh, the other complexity has to do with observability, like we briefly touched upon before, that not knowing how your components interact and how different pieces that make up your software come together to give you that business outcome that your business desires. Sometimes that can be adding to the complexity as well. But yes, these are some of the examples that I see. Really, observability especially is not really something that folks tend to care about until it bites them in production, when they are not able to see the logs or traces or the metrics and truly understand their system's performance or behavior. That's when they really invest in observability. It becomes an afterthought initially, but yeah, it is a very important first class concern for any application or any system in production.
Definitely, let's stick on observability for a second, because there's a lot to understand about observability, right? These services that we're using, everything's hosted. It will kick out IO whenever it feels like it, and it does seem like while you're using it, you can't really see what's happening all the time. Do you have any tips or tricks on, you know, things that engineers would sort of consider when they're using cloud native services, and like how to really observe it properly? Should they just use X-ray? Should they make sure certain things are enabled, or how does that work?
Yeah, I mean, without even talking about specific services, I like to think about all the concerns that developers should be aware of. Like distributed tracing, which is what X-ray really is again a very important thing to have within microservices architecture. Uh, Even in a monolithic application is never going to run on its own. It is going to interact with the database. It is probably going to write to a queue. So just understanding all the different hops that you have within your system and where they may be bottlenecked or you may have performance challenges, those kinds of concerns become very apparent when you have distributed tracing. And going back to logs, traces, and metrics, you should care about them very deeply, because logs or it did not happen is a really it rings true in every sense of the way, because the first place developers scramble to troubleshoot any issue is finding logs. And if you don't have the right level of details in your logs, or if your logs are not giving you an accurate picture of what your application is doing, your troubleshooting can take a long time. So I don't really, I'm not too opinionated about how developers or organizations choose to implement their observability, just as long as they're doing it and paying attention to these concerns. have the right granularity of metrics, have the right level of log details, have the right traces, they'll thank themselves later for having done that, because they'll see that their lives become much easier in operating the workload in production.
When we're looking at different systems and one of the first things that pops up is like, maybe we're spending too much in CloudWatch logs, can you go clean up the logs? That's like a it's like a common thing I hear, like, go clean up the logs. And then when you get in there, you realize that, yeah, you're not logging the correct stuff. Like, a lot of these logs are still kind of almost like debug statements. They're not very meaningful to the application state, right? So I have folks think about um, the logs themselves as actual useful pieces of application state, like got here, right? It's like the very first debugging tool I ever learned was the console log, and it was like, got to do all these things, and then you would write console log dot got here, and then the state of your application. And that's how I tell people how to treat the logs. It's not like you don't log every single transformation you've done. You just want to know at what state was this application when it blew up, right? Um, but that also leads me to I've had the same way. I feel the same way about IAC, infrastructure as code tools. People ask, which one should I use? Which frameworks? I was like, just use one. As long as you're using one, I'm okay with it, because um, it coupled with observability tools lets you see the ins and outs of your application from a very high level. Like, you could actually, just collapse all that YAML down to the top lines, and you'll be able to see all the individual resources you're spawning, right? Like, here's my gateway, here's all my network stuff, here's all my database stuff, and it's all in that YAML file or that cloud formation file. And I think that's the one thing, like, I'm trying to get developers to be able to see their infrastructure more ephemerally, and I want the DevOps folks to be able to think like, oh, maybe we don't need to keep these things running so hard all the time. We can learn to automate more, right?
For sure, yes.
How about IAC for you? Is that still an issue when you talk to clients, or is everybody pretty much on board now?
No, I think that's one area where I've seen a lot of adoption. So everybody's using something or the other. I used to work with small and medium sized businesses. So there I still find sometimes that folks have created a lot of infrastructure using ClickOps and are now trying to bring it under IAC governance. But even they understand the importance of having IACs and avoiding some of these snowflake installs of EC2 instances, and it can get pretty unwieldy when you don't have that IAC governance. So I think that's one area where it is getting much better in terms of adoption. Uh, Terraform, I see a lot of adoption for, with the aspiration of being multi-cloud, but I don't really see a lot of multi-cloud myself. That's another thing where my first advice to most customers is pick a cloud and go with it and build your skill set on that cloud. I feel your operations folks will be really happy to not have to worry about these similar constructs from across cloud vendors. So yeah, if it's AWS, great for us. If it's not AWS, great for you. Pick a cloud and don't get mired in the idea of multi-cloud. Uh, but yes, Terraform has seen a lot of adoption with the promise of multi-cloud. CloudFormation, I'm a big fan of CloudFormation. I know some people dislike it with a
You're
passion
old
because
school. You're old school. You want to go in there with a ruler. You're like the guy that has a slide rule on his desk. That's not me. I'm the total opposite. I want to do as little writing as possible. The less I write, the less errors I have.
that's true. I mean, JSON and YAML are not everybody's cup of tea. So that's why we have constructs like CDK, which again, many of our customers have adopted, and they find that it goes very well with their development workflows. They can check in CDK code into their Git repositories the same way they check in their application code, and they have this whole process behind it. So yeah, there are quite a few options with IAC that customers are starting to get familiar with. But going back to your point, just pick one and use it, right? Don't click ops. Never click ops.
Yeah. Oh man. I mean, it's one of the more frustrating things when AWS does come out with something and there isn't a way to properly launch or deploy it, with IAC. Some of these newer like low code, no code stuff, it uses services that I think we ought to be able to tap into and like amalgamate, but it doesn't give you like a direct API into it because it's like this low code thing. I see that a lot in the what is it called? The BI tooling that's in it, QuickSight.
Quick site, yeah.
Yeah. But okay. Well, how about like the future of simplicity? I guess if we were to look forward and say like we got a lot of great tools now. We know we
Hmm.
got problems to tackle, and we can kind of decompose the complexity into like its different domains. Okay, and we're
Hmm.
upgrading our tools, and we're being very thoughtful. But like, what's still on the horizon in your work? What do you still have to uh, like go out and champion for coming up in the next year or so? That is gonna increase the simplicity, as I suppose.
Yeah, I guess it's not something that is looking forward or looking back, but something that has existed for a while, right? Like just the idea of letting go of control and let the vendors do the heavy lifting for you. And when I say vendors, usually AWS, right? We come with the promise that we have these managed services, which does most of the heavy lifting for things you're probably not going to need to have the control over or the flexibility over, because many times flexibility is something that customers desire for things that they probably never need flexibility for in the first place. So let let the managed service do the job for you. And as with serverless first, I usually advocate for start with managed services first. And yes, if you find yourself backed into a corner where you absolutely need the flexibility that the managed service does not offer, sure, yeah, host it yourself or find an open source library that you can run on an EC2 instance and control every bit of it. But you're probably not going to need that on day one. So I think the idea of simplicity is going to come from the habit of letting go of things that you don't need control over, because the more things that you try to control yourself, you're really adding to the accidental complexity. Hyperscalers are operating these systems on a daily basis with the availability and reliability guarantees of 99.99. And if you are aspiring to be 99.99 someday, do you want to do it all yourself or work with somebody who's been doing this for years, and maybe you can just piggyback on the availability guarantees or SLAs that come with adopting their technologies? And that's something that every organization needs to think about. How much of this do I want to uh, do myself? I'm sure we have the smartest engineers in the world, but is this worth our time to try and do something that somebody like AWS is already solving for us, so we can focus our engineering time on adding more business value? Or do you want to build the most beautiful Kubernetes cluster and keep it operational 24 cross 7 and own it all yourself, right? So yeah, that's the trade-off. And again, control versus simplicity, that is an important thing to consider.
Always comes back to these trade-offs, right? Like um the idea of using IAC to be able to deploy across multi clouds is a huge trade-off, right? Because I've been telling people like I've never done a true multi-cloud project because when I think about it, when you try it with just like say Terraform and you try to do both AWS and Azure, it feels like when you get the Lego bricks from the dollar store and you have your real Lego brick at home and you put it on and like sometimes it stays on, but then sometimes it just randomly pop off. And then you got to have like a second real Lego brick to like squeeze in between so you know you get a good like fit. that's exactly how like my experiments in multi-cloud deployment went. It was like just close enough, but not good enough.
Yeah. I'm sure somebody out there has a good multi-cloud story. I haven't heard too many of them myself, although I understand when somebody says they want to be multi-cloud, but I feel like there again, they are taking on more than they need for situations that may never occur.
Sure. I mean, it's easier again, like I wish things were region free, but it's easier just to have a check that say, is this region? If not, then this region, it's already duplicated somewhere else. So, there are ways you know, to mitigate with redundancies in all of these systems, right? And as long as you're kind of, I tell people, as long as you're in their SLAs, right? Like AWS is going to guarantee so much bandwidth and so much space. And if you're inside of that, then that's up onto them, right? That's what you're paying for.
Hmm.
Cool, man. Well, we've talked about a lot, didn't we? Yeah, we went all through the different many layers of complexities. Even got some network science theory in there too. So I really appreciate the time you've taken to kind of hang out and chat with me today. But before we go, I have the most important questions, the ones that like I really want your hot takes on. Right? Okay. You deal with a lot of data. You deal with a lot of like decisions. So you got to make a choice. You got to tag. You got to add meta tag to this thing. Is a bowl of cereal a type of soup?
Ooh. uh, I don't know.
Just think it out loud. Like you're putting together a menu. You've got a soup category. Chef says, here it is." They hand you a bowl of cereal. Are you going to argue with him? Or are you going to put it? Are you going to just classify it as a soup?
Yeah, I would argue with him or argue with the waiter just for the fact that I'm not a huge fan of cereals myself. So
Okay.
for that reason, I probably will say that yeah, this is not the soup I ordered. But even generally thinking, I like my soup savory, and cereals tend to be more on the sweeter side. So yeah, to me, a bowl of cereals is not a soup.
Okay. Yeah. When you have it on the dimension of savoriness, that's a very common thing when we're trying to decide like is something one or the other. Our brains go ahead and trip into a like it'll rotate into a different dimension that wasn't even considered at first, right? And now we're making this assumption on a tangential dimension that wasn't the original question. And that is why I love doing this show. Well, yeah, like thank you again so much for coming on, talking to me. Where can people find you or learn more about the stuff that you've done? I know you were at AWS Summit Toronto. Did they record that? Can people watch that yet?
No, no. That was a chalk talk. We don't record chalk talks, but I will be speaking at reInvent in December, and this time it will be recorded. I encourage anybody who's going to reInvent to find my session. It's already out there in the catalog. You can look the session up by my name, and it will be recorded. So if you're not able to make it, you can always watch it later.
What's the name of the session?
It's called Capability First Architecture, bridging business intent to technology. I hope I have that all right, but yes, that's the name of the session. So it expands upon the same idea that I spoke about in the Toronto summit, but we have some newer ideas that we are going to talk about this time.
Very cool. And you've also written like white papers or a book, I think.
Yeah, so I've authored a bunch of blogs on AWS blogs, but more recently I had this opportunity to write my first book, and that was again related to automations that are possible on AWS using our native tools. So lots of event bridge, lots of step functions, cloud formation. So I talk about all of that, and yeah, for anybody starting out on AWS and are looking for ways to simplify their operations or SRE concerns using automations that are possible on AWS, yeah, I think it could be a good rate.
Perfect. Oh, that's awesome. I'm gonna have to definitely check it out. Um, and yeah, thanks again for coming. Thanks everybody for tuning in today with talking serverless with me and Sushanth, and we talked about how complex things could be simplex. I don't know. I'm not Werner. I don't get paid the big bucks to make up new words. But that's it, everybody. Definitely check out the other episodes, like, subscribe, smash all the things. And yeah. Oh, also today's episode, as always, brought to you by Serverless Guru, sls.guru.guru. Check us out. We're doing lots of really awesome work with clients all around the globe, making the most of their cloud. So thanks. We'll catch you on the next one.